separation and different degrees and spinning or rotation of the bulb. So ideally, the recovered hexane would be 100%, which is impossible almost to achieve, the ideal. And then its density would be 0.658 grams per centimeter cubed. And then the oil that's recovered, avocados in the flesh contain 8 to 30%, so anywhere in that range would be acceptable. And then the density should be really close to 0.92 grams per centimeter cubed. So these are our results. So the separation process is the separation process is the weight that went into blending, and then the weight taken out of the separation, the weight after separation. So it just it records what has been lost through the blending and the filtration process. So we got 81.1% separation with recovery on that, so that was really good. Recovered hexane, we averaged 58.8%, not 100, but very high. And then extracted oil, you can see its density was 0.733 on average. And we did have a few runs that were like 0.89, 0.88, something like that, very close to the ideal density that we were looking for. But this just indicates that there's still hexane left over in the oil. So the 24.6% is the average if that density was 0.92 if it was all oil. So this is probably going to be a lower number if we just extracted oil and there was no hexane left over in our oil bowl. So this is comparing our results to previous colleagues' results. We have 3 old reports that we found really useful, making our procedure and adapting changes to it through theirs. So you can see that after the separation process, using the homogenizer and the beaker filtration and various methods, our recovery was much higher compared to 66 and 76. In the extracted oil, our density was low on average, but the percent recovered was still in range. And we do have a few runs that doing various things helped make that density much higher, and I'll go through that in a minute. And then the hexane recovered, you can see we have the highest percentage on that. So that's really good. And our density is also almost spot on, slightly off, which could be looking at the volume or within air of operation. So in conclusion, the best dehydration method was with the skins. So we cut them up and dehydrate them in their skins and then de-skin them after that process. The homogenizer obtains the best recovery. You don't lose as much with that, and it also breaks down the cell walls way more than a typical blender can or any other process that's been used, so the hexane can really come in contact with all the oil. And then the best separation method that produced the best results was the beaker funnel with no filter paper. When you do that, you just have to be sure to clean out the beaker funnel right after you do it, or else you'll just clog it up for good. Limitations of this was the ripeness of avocado that we used. In some resources, the more ripe an avocado is, the more oil percent it will contain. So we tried to let them ripen a little bit, but we did have 2 or 3 avocados that came out looking like this once we waited long enough. Another limitation was the volatile solvent. Hexane evaporates at 67, so when you put your hand on the beaker, it starts evaporating out, or even the room temperature is right about there, between 2 degrees of its boiling point. So the whole time you're doing that, hexane's evaporating off. Interchanging equipment, every time you switch from beaker to beaker or the beaker funnel back into the bulb, there's always a little bit of residue left. And then the other limitation was the complete removal of hexane. Clearly from our oil density that we extracted, it still contained a lot of hexane in it, even though we let it sit in the rotary evaporator for 4, 5, 6 hours. The EHS, PPE stuff, hexane, it's a skin contact, ingestion, and inhalation problem. It's also extremely flammable, and then the hexane can be used, if you recycle, it can be used again for extraction purposes. So wanted to make sure to recycle that. And then PPE, splash-proof goggles, protective nitrile gloves, sleeves and pants, and then the homogenizer. It can be very dangerous. You don't want to put your hand anywhere close to it, and so forth. So we exercise extreme caution with it. So recommendations: allow the avocado to ripen, but don't allow the avocado to mold. It's gross. Minimize equipment interchange. Try to find something that you can weigh and take the volume of without having to switch back and forth to different containers. So you can homogenize it and all that in. Vary amount of solvent. We just use a 3-to-1 mass ratio, which we found from a resource, but who knows if it would work better or worse with more or less solvent. So that could be something that could be experimented on. And then after talking to Dr. Thomas, once we finished all 10 samples, she suggested that bring the rotovap temperature up to like 95, where you're not evaporating the water off, but down at the very end when the composition of hexane, the mold composition is much less than it was, it's really hard to get that last little bit of hexane out of it. But if you bring the temperature up for a second, for like the last 5 to 10 minutes, then perhaps that would get more of the hexane out. And then the last recommendation is record everything. In between every process, take the weight, take the volume, so you can look at densities. That tells you a lot of what you got with you. This is the resource. Is there any questions?